Have you ever stopped to wonder what's really happening when you log into a secure network? It turns out there's this invisible gatekeeper deciding if you get in and what you're allowed to do. So today, we're going to pull back that curtain and take a look at the system that makes it all work.
I mean, it kind of feels like magic, doesn't it? You just type in a password and poof, the digital doors swing right open. But what's actually happening behind the scenes to verify that it's you, and then to decide what you're allowed to see? I mean, this is a process we all go through dozens of times a day without even thinking about it.
And the answer, you're not going to believe this, works a lot like this familiar piece of plastic right here. A credit card statement is actually going to be our guide today. And believe me, it is the perfect analogy for demystifying this whole world of digital access control.
This entire process is managed by a framework called AAA. Now that might sound technical, but it's a real cornerstone of network security, and by the end of this, you'll see exactly how it works. So, let's dive in. So, what are these 3 A's? Well, let's break them down, and we're going to use our credit card analogy to make it super simple.
If you look at a credit card statement, it contains 3 key pieces of information, and you'll see that each one maps perfectly to one of the 3 A's. It's kind of brilliant.
Okay, so the first A is authentication. Think of this like presenting your credit card to prove it's really yours. It answers that one fundamental question: who are you? In the digital world, this is your username and your password. Simple as that.
The second A is authorization. Now, this is like your credit limit. It's not about who you are anymore, it's about what you're allowed to do. So on a network, this is what determines which files you can open, what apps you can run, or which servers you can get into. And the final A is accounting. This is just like your transaction history, that detailed log of what you bought, where, and when. In network terms, this means tracking what resources you used and for how long. And this is absolutely crucial for security, for auditing, and yeah, sometimes even for billing.
Okay, so the analogy makes sense, right? Credit card, network, got it. But how do these concepts actually work on a real computer network? Let's shift from that analogy to reality and see how this all comes together to build a functional security system. So, here's authorization in action. Your computer, the client, makes a request, but it doesn't just get a direct answer. Instead, the router acts like a go-between, asking the central AAA server, hey, is this user allowed to do this thing?
It really is a simple 3-step dance. First, a secure session gets established. Second, the router makes that specific request on your behalf. And third, the server sends back a really simple, decisive answer: pass or fail. It's basically a digital permission slip.
Now, let's look at accounting. Once you're authorized, the network needs to keep a record of what you do. So the router communicates with the AAA server again. But this time, it's sending messages to log the exact start and end of your session.
And I just love how this visualizes the simplicity. As soon as you're authenticated, a start message gets sent. It's like starting a stopwatch. Then when you log out, a stop message is sent. And just like that, the server has a perfect, detailed record of your session.
So we know what AAA does, but where does all this happen?
Well, there are 2 main ways to set it up, and the choice you make has huge implications for a network's scale and its security.
And here are the 2 approaches, side by side. On the left, you've got local AAA. This is where the router itself stores all the user information. Then on the right, you have server-based AAA, where the router has to reach out and check with the separate central server. Let's really break down the difference here. Local AAA is super simple, and it works just fine for a tiny network with maybe a few devices. But can you imagine having to update passwords on hundreds of routers one by one? That would be a total nightmare. And that's where server-based becomes absolutely essential. It's built to scale, and it gives you one central point of control for everything.
Now, for the server-based communication to work, the router and the server need to speak the same language. These languages are actually standardized protocols. The 2 most common ones are called Radius and TACAX+. You can just think of them as the official rulebooks for how the AAA framework communicates.
Okay, so we've covered the what and the how. Let's wrap this up with the most important part: the why. Why is this AAA framework so incredibly critical for any secure network out there?
The benefits really boil down to 3 main things. First, you get incredible flexibility and control over who does what. Second, it's highly scalable, so your security can actually grow right alongside your organization. And finally, because it uses standard protocols, gear from all different vendors can work together seamlessly. No problem.
This quote from the source material really just says it perfectly.
It's not a single product you buy, but an architectural framework, a consistent, reliable way to manage three separate but related security functions. So in the end, AAA just brings it all back to those three simple questions we started with. Authentication asks who can get in, authorization asks what can they do once they're in, and accounting keeps a record of what did they do.
For decades now, AAA has been the silent but absolutely essential gatekeeper for our digital world. It's robust, it's proven. But, as technology evolves with biometrics and AI, it really makes you wonder, right? What will the gatekeeper of tomorrow's internet even look like? Well, that's a thought to leave you with. Thanks so much for joining me on this explainer.